Alien Dyson spheres could really exist, but only in this one type of star system, a new study hints. Is it possible to build a Dyson sphere that is not catastrophically unstable? New research says yes, but only in one type of star system. Dyson spheres, the hypothetical megastructures that advanced alien civilizations might use to enclose a star and harness its energy, suffer from a fatal flaw. They are catastrophically unstable, but now an engineer claims to have figured a way out to stabilize these structures, and all it takes is 2 stars. In the 1960s, physicist and polymath Freeman Dyson cooked up the idea of these eponymous spheres. He envisioned that a sufficiently advanced society would have an insatiable need for living space and energy, and if they were industrious enough, they could solve both challenges by taking apart a planet and turning it into an enormous spherical shell. This sphere would enclose a star, providing billions of planets worth of surface area and capturing vast amounts of solar energy. Dyson calculated that a shell made from a planet with a mass of Jupiter could completely enclose the Sun at roughly the orbit of Earth. But the gravity inside the hollow shell cancels out, which means there's nothing tethering the shell to the star. They're free to move in independent directions, which means that soon enough the star hosting a Dyson sphere will simply crash into the shell, destroying it. In a paper published January 29 in the journal Monthly Notices of the Royal Astronomical Society, Colin McInnes, the engineer of the University of Glasgow, found a way to theoretically stabilize a Dyson sphere. The trick is that you need the system with at least 2 stars. Hunting for stable Dyson spheres, McInnes started by searching for any points with a binary star system that could host a stable Dyson sphere arrangement where the sphere could stay in place and the gravitational forces exerted on it would be uniform. He found one arrangement where the sphere surrounds both stars, but that situation was only mildly stable and likely to suffer the same problem as a single star case. Another stable point arises when the sphere orbits independently, surrounding neither star. While this might be useful for space station outposts, it does not provide the energy capturing benefits of englobing a star. Now, McInnes did find one stable and useful configuration. This only happens in binary systems in which one star is much smaller than the other. In that specific case, the Dyson sphere can enclose the smaller of the 2 stars. The motion of that smaller star acts like a gravitational anchor, keeping the Dyson sphere in motion with the same orbit around the larger star, preventing a catastrophic collision. There are several caveats to this. The smaller star has to be no bigger than around 1/10 the mass of the larger companion, otherwise the gravitational stable point disappears. There's a sphere that has to be extremely light and thin compared to the 2 stars, otherwise its own gravitational influence mixes into the dynamics of the system and destroys the stability. And of course, the analysis ignores any practical engineering considerations like the stresses and tensions a sphere might experience, or how to build the thing in the first place. While it's unlikely humans will build a Dyson sphere in the distant future, if ever, this research does help inform searches for extraterrestrial civilizations. Presumably, a scientifically advanced civilization would have made the same realization before building its own Dyson sphere, and so we should not look for them around any solitary stars. Instead, scientists could look for large, bright stars with a diffuse infrared companion. The telltale sign of the heat leaking out of the Dyson sphere encloses the smaller star of a large companion. And this is by Paul Sutter on Live Science. Please leave your comments and thank you for your support. Please support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.